Simplifying those trig expressions, that took some work. Good thing we had a break. All right, but we're back now. And we are still talking about section 10.1. We're going to look at two more examples of using fundamental identities to simplify each expression. It's not always clear what it means to simplify an expression. Usually you have some sort of clues about that, like this is a problem in calculus and we want this final expression to be in this particular format. So we're kind of told that in these examples, our final answer is either going to be a constant, meaning a number, a single trig function such as sine x or cosecant of x or cotangent of x, or a power of a trig function such as cosine squared x. Okay, so again, it's hard to say at this point why this is really relevant, but what this does is our job in this particular section in working with manipulating these trig functions and these expressions is to use our toolbox of fundamental identities. And I kind of think of this as a bit of a puzzle. We want to use these identities to rewrite this expression here so it's cleaner, nicer, and simpler for whatever reason we're going to be using it down the road. Okay. All right, so in this example, we have cosine of x over secant x is equal to sine x over cosecant of x. And I don't see any powers on here. I don't see any squares, so I'm probably not using the Pythagorean identities right now. And I can't really combine these fractions because they don't have the same denominator. So if all else fails, my strategy is to turn everything into sines and cosines. Now in this first fraction, I have cosine of x, that's already a cosine, but I have secant of x on the bottom. And so I want to remind myself, secant of x, well, let's see, in terms of our fundamental identities, secant of x is the reciprocal of cosine. So secant x is 1 over cosine. So secant of x is 1 over cosine x. And over here, I see sine of x divided by cosecant of x. And cosecant is the same as 1 over sine. So cosecant of x is 1 over sine x. Okay, so replacing pieces, I have cosine of x over, oh, I know it's tough. Here you go. Replacing secant x, I can replace that with 1 over cosine x, and I can replace cosecant of x with 1 over sine x. It looks like I just made things a lot worse. Things look more complicated, but that's okay, because I also know that when I divide by a fraction, that's the same thing as multiplying by the reciprocal. So I can write this as cosine of x times the reciprocal, so times cosine of x over 1. And I can do the same thing with the second fraction, and I get sine of x times the reciprocal, so times sine of x over 1. All right, great. Cosine of x times cosine of x over 1. I don't really need to worry about the 1 in the bottom. I can ignore it. And what the cool kids do is they look at this and say, all right, cosine of x times cosine of x, that's the same as cosine squared x. Sine of x times sine of x, that's the same thing as sine squared x. And suddenly, I look at this. I've got cosine squared x plus sine squared x. And that, my friends, is half of the best trig identity in the entire world. The identity that says cosine squared theta plus sine squared theta equals 1. Best trig identity ever. This whole thing right here is exactly equal to 1. So this whole mess of a fraction up here is actually exactly equal to 1. Boom. Okay. So that is our example. One more example to look at. I do want to make one comment though. As you are working on these problems and as you are writing out your remote assignment, and in life, and in your calculus class and your physics class, there will never, ever, ever be a time when you will write down COS without something after it. There will never, ever, ever be a time when you will write down sine without something after it. Always, when you're writing down the trig functions, have some kind of an argument after it. Cosine of theta, sine of theta, cosine of x, sine of x. So you always want to make sure that you have that input written next to your function. Bless you. Okay, so our final example is 1 over tangent squared alpha, we're using alpha as our input this time, plus cotangent of alpha times tangent of alpha. All right, and our job is to simplify this expression. Now, we have a lot of different ways that we could go about this, and I want to encourage you to try to simplify this in a different way than what I do in this video. This would be a good question to check in with on your point of contact. You could send maybe a PDF and say, hey, I simplified this in a different way. Diane, can you look at it? Okay, so here are some things that I might do. One option is to turn everything into sines and cosines. And that's one way that I would recommend for you to look at this guy. You're going to be okay. This first guy here. One over tangent of alpha. If I look at that, and then I look over here at our fundamental identities, I do see a 1 over tangent, and that's the same thing as cotangent. So 1 over tangent of alpha is the same as cotangent of alpha. Okay, so 1 over tangent squared of alpha would be the same as cotangent squared alpha. All right, that's great. I also know that cotangent of alpha is the same as 1 over tangent, so I can replace cotangent with 1 over tangent of alpha times tangent alpha. Okay. If I do that, this tangent on the top and this tangent on the bottom cancel each other, leaving me with a 1. And so I have cotangent squared alpha plus 1. Okay, so I stop. I take a step back, and you might not see this in the video unless, maybe you are now. You can really see me stepping back. Go ahead and show me stepping back. Stepping back and looking at the board from a different perspective and saying, okay, what do I have now? And what I have now is a trig function squared combined with a 1. This looks to me like a Pythagorean identity because it's a squared trig function involving cotangent. Cotangent squared theta plus 1 is the same as cosecant squared theta. So cotangent squared alpha plus 1 is the same as cosecant squared alpha. So I can replace cotangent squared alpha plus 1 with cosecant squared alpha. Now I have a trig function, well, a power of a trig function. Okay, now on this example, you might say to me, Diane, I would never have thought to turn cotangent into 1 over tangent. I mean, that's cool, right? Because it cancels the tangents and things go away. What do I do if I don't see that? And the answer is, if you look at this expression and you say, I have no idea where to go with this. You're crying like Ariana, saying, I don't know what to do. Turn everything into sines and cosines. And I encourage you to try that. And check in with me on your point of contact. All right, thanks for listening. Good night.